Today is Tuesday, December 17th, 2024. That moon is finally starting to wane away. Thank goodness for that. Though all that luck that I was bragging about a couple weeks ago around new moon, yeah, that's kind of gone out the window with full moon. It's been pretty much cloudy or nothing as of late. So if there's not clouds outside, then there's a big bright full moon, which is always wonderful. But glad to be back with you guys week before Christmas. So just a little bit of housekeeping. As you might have imagined, I probably will not be releasing an episode next week just because our release date is right about when Christmas is. I think it falls on Wednesday next week, and generally I'll come out on Tuesday or Wednesdays with new episodes. But I think I'll end up spending the time with my family. Please don't kill me, and please come back the next week, because I promise we'll be back. I won't use New Year's as an excuse to, or I'll try not to. No promises, but I hope everybody has been well. Even though I have not been able to do any actual astrophotography, I have been rather busy with a lot of different astronomy and Astrocast related items. And I kind of thought it might be fun to talk about something a little bit different today than what we normally talk about. It's still going to be very much astronomy related, but perhaps in a field that we don't often get to talk about. And well, let's start by going with a recommendation for a very cool movie that came out way back in, I think it was 1996. It might have been 97. It was right around that time when the movie Contact came out. And if you haven't seen it, it is definitely worth seeing. And it is a big proponent of radio astronomy. That is what the story of Contact mainly focuses around, and that we receive our first contact from an extraterrestrial race from the Vega star system, and then kind of everything that unfolds from there. I won't spoil it for you, but it's a really, really good movie if you've never seen it before. It's just cheeky enough to where it's not like looking down its nose and how corny it is at you, but just corny enough, in my opinion, to where you can watch it and truly enjoy it. Gets geeky enough when it needs to, but doesn't go, full science guru on you, which is a little bit of a surprise because the story, and I can't believe I didn't know this, but apparently I was under a rock and everybody else knew. Contact, the movie, is actually based on the only sci-fi novel that was ever written by one Carl Sagan. You may know him, kind of the granddaddy to us for all things astronomy. He was not someone who was huge for my generation coming up, but the generation just before mine, so like your Gen Xers and boomers even, got to see Carl Sagan in his prime when he was, I think you might say the Neil deGrasse Tyson of his time, or we might say Neil deGrasse Tyson is the Carl Sagan of our time, which would probably be a lot more appropriate. And I'm sure Neil would definitely say the same thing if someone were to ask him about it. So anyway, I mentioned the movie Contact because at the beginning of the movie, you get a look at one of the very best telescopes in the world for radio astronomy. The Very Large Array, which is actually located in New Mexico. It's actually a place called St. Augustine, and I'm probably botching the pronunciation of that. But I do know it's at an altitude of about 2,100 meters or 7,000 feet for our American listeners. Very, very good place to do radio astronomy. It's actually in a radio dead zone. You're not allowed to play FM radios or use cellular devices in the area because they don't want interference. And that's very, very crucial when you're doing radio astronomy, because we have so many different forms of radio emissions that go through our air at any given time that you're just constantly battling in interference. And, if you think that noise is bad in the beautiful photos that we're able to capture in a matter of a few hours, imagine having to contend with, Wi-Fi and microwaves and cellular phones and everything else that radio telescopes actually have to deal with. But they showed the VLA at a couple of scenes within the movie Contact. And it's actually, if you've never been, I have not. It is a place that I very much would like to visit. It was up on my list of large telescopes that I want to see one day when I'm an adult that I have not seen yet, including Arecibo, which sadly I will not get a chance to see now that Arecibo is no longer with us. It was actually one of the largest of all time radio telescopes that was made up of a single dish that was 1,000 feet in diameter. So incredibly very, very, very large for its day. It was built in 1963. And like I say, it didn't collapse until 2020. But Arecibo was also shown in the movie Contact. Arecibo coincidentally actually held the record as being the largest single aperture telescope in the world all the way up until 2016. So you figure from 1963 all the way to 2016, with all the technology that we have had over that period of time, it remained the largest single aperture telescope in the world. Now, when it was overtaken in a pretty big way by China's FAST telescope, which is actually more than, let me see here. Okay, I'm laughing to myself because FAST is actually the acronym for it. It's the 500 meter aperture spherical telescope. So yeah, it got overtaken in a very, very big way when the FAST telescope officially went online in 2016. And it's just an absolutely massive radio telescope at 1,640 feet in diameter. For context, that's about 30 football fields all put side to side. Just absolutely massive is that new FAST telescope. But back to radio astronomy as a whole. I'd always kind of wondered a lot about radio astronomy and what we actually do with that data. I think there's always been a little bit of a question to me. Like, I know that we, use it for detecting faint radio signals, obviously, hence the name, right? Radio astronomy. But I wonder, like, what are those actual radio signals made up of? So, what is it that we're actually seeing when we point a giant telescope in space and then, point it at a particular star system or galaxy? Like, what is it that we are actually looking for? So they've obviously, they do a lot. That's to put it lightly. But I thought it might be interesting to talk about some specific things that the Very Large Array and the Arecibo telescope have actually discovered and how they have discovered them. So one of the biggest notable things that the VLA was actually able to do was confirm the presence of water ice in Mercury's poles. So even though Mercury is, obviously very close to the sun, those specific craters where that ice is located, they don't ever receive direct sunlight. And by pointing the Very Large Array at Mercury, and specifically at those areas that do not receive that sunlight, they are able to detect radio signals that confirm ice is actually there. So that's kind of wild to think about something being as far away as Mercury, which is, anywhere from 50 to 150 million miles away from the Earth at any given time, and, detect something as seemingly insignificant as ice. So that's the kind of detail that you're working with when doing radio astronomy. So not only that, but they can be used for things like probing black holes, apparently. So the VLA actually was one of the very first telescopes to take pictures of material actually being ejected from black holes. So that's how we were able to actually, find evidence that black holes are, affecting their environments around them by seeing the actual, jet streams of material being created around the black holes. And it was actually used to observe Sagittarius A, which is the supermassive black hole at the center of our own galaxy. So I'm sure you've seen the very, very famous picture that is the first, photograph taken of Sagittarius A. Well, the VLA and its radio telescope played an absolutely key and pivotal role in getting us to the point where we are able to actually image a black hole like Sag A at the center of our own Milky Way galaxy. Now, beyond that is where you get into some really interesting scenarios as far as detecting, different things within our night and daytime skies, which is another reason that makes radio astronomy very interesting to me, is the fact that it can be done during daytime hours. And we're going to talk about that a little bit later in the challenges that it presents, because it does actually present some unique challenges to radio astronomy, being done during the daytime, but it is actually doable, which is not something that we can say about our visual or photographic astronomy as we have it today. Now, there are some super advanced cameras out there that can somewhat do photographic astronomy during the daytime, but I would think for the average astronomer, there's no chance that they're going to get anywhere near gear like that. So I'm going to say, daytime observing is generally speaking not a thing for us, unless, of course, you're looking at the sun and perhaps Venus to check out what stage she is in. But the beauty of a radio telescope is, since it's picking up these radio waves and signals, it can detect things like pulsars and neutron stars, because they emit their own very specific radio signals, and they generally emit them on a pretty regular basis. And that's how we're able to, confirm that they are actually there. Binary pulsars have actually been discovered and were discovered first by radio telescopes. And they actually play a large part in proving the theory of general relativity. Binary pulsar systems do. And that didn't take place until decades after Einstein had theorized it. And yet radio telescopes actually brought us confirmation that neutron stars can produce binary systems. Just like we have our regular binary two sun systems, you can also have a binary pulsar. Pulsars, incidentally, are already pretty wild on their own in the way that they behave in the absolute extreme conditions that they cause. Pulsars are so important to science because we are able to study the absolute extremes of physics within the areas of pulsars, because you have such extreme conditions happening around a pulsar that you are not able to recreate literally anywhere else in the universe. For example, just how fast they spin. So pulsars are neutron stars that actually form when a really massive star explodes in a supernova, and then they leave behind a neutron star. And what's crazy about them is, like I say, they can rotate incredibly fast, and they can rotate so fast because in terms of astronomical objects, they're incredibly small, and yet they are also incredibly dense objects. So pulsars are made up of the densest matter that we can find in our universe. And, an average pulsar might only be as big as, a small city, 10 to 15 miles across. But even at that size, the speed with which a pulsar rotates is completely mind-blowing. So when we first observed young pulsars, they were rotating anywhere from 10 to 100 times per second. And those are young pulsars. So imagine an object, a spherical object about the size of a city that is rotating over 100 times every single second. And then you begin to understand why pulsars give off such strong energy, universally speaking. Now, beyond that, they can get even more extreme. There is a second class called millisecond pulsars, and those can rotate over 100 times per second, as the name would suggest. And in fact, the very fastest pulsar that we have located rotates over 716 times per second. So just imagine the amount of energy that something that dense, that densely packed, and that size rotating that quickly gives off. And then you begin to understand why even a faint radio signal from, 100 million light years away can be relatively easily detected by an object like the VLA. Now, older pulsars often spin a lot slower. They might spin, once every few seconds, or they might even go a few minutes. And that's, basically them losing their energy and slowing down over time, which is obviously also going to cause them to produce less radio emissions. And being slower pulsars, they'd obviously be harder to detect. I would imagine, I am not a radio scientist, but just based on that fact, I would imagine that they would be somewhat harder to detect. The VLA has also quite famously studied the Orion region, basically just to study exactly how star systems and planetary systems actually form. It's been able to detect very, very faint radio emissions, basically from the earliest stages of stars, to detect exactly how star formation begins and exactly, why it is caused, how it is caused, and all of the science that goes behind it. See, as far as targets go, the VLA has actually touched on many targets that we as astrophotographers often like to shoot at. It is also very famously mapped to the supernova explosion that is the Crab Nebula, and also Cassiopeia A, which is another pretty famous target for many astronomers to check out. Now, some specific ones that Arecibo is famous for, since it's so much older, the first binary pulsar that was ever discovered was actually discovered using Arecibo by two astronomers, Russell Halsey and Joseph Taylor. And that actually provided the first evidence that we ever had for gravitational waves, which is exactly what we were talking about earlier when we were talking about how it proved large portions, it tested large portions of the theory of general relativity that Einstein had came up with decades before. And that actually ended up winning them a 1993 Nobel Prize in physics. So yeah, Arecibo definitely also quite famous. It was also a pioneer for SETI. I forgot to mention, I wanted to mention that earlier, but just like in the movie Contact, they were obviously using the VLA. Arecibo was actually also pictured in Contact, and they were actually central to the SETI project because for a long time, Arecibo was actually used to try to detect signals from extraterrestrial civilizations. It also helped map the surface of Venus. Arecibo did, which is pretty darn impressive. It actually helped us study a lot of asteroids that are dangerously close to Earth as well. And then both the VLA and Arecibo are both huge in finding the so-called fast radio burst. If you've read about FRBs, which are very fast bursts of radio waves that get picked up by these telescopes and then tend to repeat on a normal cycle. They've been in the news a lot over the last few years, so you've more than likely heard about fast radio burst, whether you realize it or not. But they actually are detected largely in part due to telescopes like the VLA and Arecibo, of course. So something I mentioned earlier in the episode that we haven't really talked about yet is the difference with radio astronomy versus astronomy and astrophotography during the nighttime and daytime. So I had mentioned earlier that radio astronomy absolutely is done in the daytime, but it does have some unique challenges that it presents. And I was trying to think outside the box before, looking up these answers for how these types of things work, and trying to think like, how would I do it if I was designing a giant telescope for daytime hours? What would I use to ensure that it can essentially guide correctly and slew to the right spots and all those sorts of things. And a lot of the things are kind of common sense if you think about them, but they do have some pretty unique ways of handling certain things also. So for slewing, obviously they use like your standard slew drive motors and astronomical coordinates, your right ascension and declination, and the stars don't move much in the sky from day to day as far as, how we're able to view them in our night sky. So if you know where a star is for 20 nights out of the year, then you'll probably know where it is during the day for those same 20 days, just because they do, again, follow the same right ascension path at all times. But what's unique about these telescopes is they have to compensate for some really crazy stuff. So you got to think about how large these telescopes are, first of all, and you have to deal with factors like mechanical flexure, because when you're supporting a structure that is as large as a 500 meter radio dish, you're obviously going to have mechanical pressures that are taking place throughout the entire process that are going to impact things that need to be very delicately controlled, such as guiding on a star, for example. If you were to, for example, have a giant equatorial mount at home, and then you somehow got a 1,000-foot, aperture telescope that could somehow, even though it's probably physically impossible, fit on top of that mount, then you would probably need to correct for all the weight and crushing pressures that such a large telescope would bring. And indeed, they do have to calibrate for that with these very large dishes. But what I found to be really neat is how they, and I'm not a radio astronomer, to be clear, but just from what I've read, they can use what are considered to be really bright pulsars in the night sky, or I'm sorry, I keep saying night sky without even thinking about it, but in the daytime sky, they can use the location of a very bright pulsar, which is, obviously a known quantity. They know where that is in the sky at any given time. And when they know that they have locked onto it and they are getting the correct radio emission from that pulsar, then they can actually use that essentially as a guide star to make corrections for when they are actually doing radio astronomy on a completely different target. So essentially the same way that we would use a guide scope to photographically or visually look at stars and then lock onto them as they move, the radio telescope will use radio astronomy to lock on to a pulsar, and as it moves, correct to be locked on to that pulsar, just like we would use our guide scopes. And I found that really fascinating in particular, because that was just the first thing that occurred to me was, well, how are you going to track these objects during the daytime when there's no stars to actually see? But they don't need to be seen. They just need to be heard. And, I said pulsars earlier, but they actually would use a quasar, as quasars actually are much brighter astronomical radio sources than even pulsars are, as their radio guide stars, if you wanted to call them that, to get that accurate positioning in both daytime and nighttime observing. Now, I did see that a lot of times radio astronomers, if they're trying to get a uniquely faint signal, for example, then they will oftentimes wait until it is nighttime to do the actual astronomy, because obviously there are less interference waves going through our skies during the night in our atmosphere than there are during the daytime, when we're all out and about and, jamming our Wi-Fi signals out. Kind of think of it, I wonder how much of a difference it makes. I mean, I suppose people are more at home than they are out and about, but even at home, I guess in the middle of the night would be the time to do it, because you're still going to be emitting a lot of, radio waves during your daytime, or I shouldn't say daytime, but waking hours at home. And I'm going to imagine that's going to interfere quite a bit. Then again, businesses emitting their own wavelengths that close up during the daytime, that's a big one. I'm sure they have to compete with things like, radio station, 4G, 5G, even 3G antennas, and all the interference that those bring. And it's got to be a incredibly challenging job. And I can't imagine picking up what I thought was an incredible signal only to be, finding out weeks later that it was actually just interference, which apparently is a fairly common thing to happen in radio astronomy. They get a lot of false positives because of different atmospheric disturbances that can impact the actual radio astronomy. Now, it was in August of 2020, as we mentioned earlier, that Arecibo actually broke. It had a cable snap, which initially it did damage to the dish, but engineers were hoping that they would be able to repair it. But then just a couple months later in November, a second cable failed, and then it was determined unsafe for repair. And then within a few weeks, on December 1st, 2020, the actual suspension platform collapsed, and that pretty much destroyed the dish below. And that was the end of Arecibo, unfortunately. It left a huge legacy behind in the scientific world that really can't be underestimated or undervalued, I guess I should say. I actually was able to get a shirt from Arecibo. I was quite lucky after it actually fell, because it was always on my list of places I wanted to visit one day. I immediately went to their website, and they were still selling T-shirts like you could buy in their gift shop. And you actually ordered them from the actual Arecibo page, which was kind of neat, because it wasn't just somebody, drop shipping it to you from God knows where. I mean, heck, it probably was, but it sure didn't look that way. And I was able to get one, and I still have that Arecibo shirt. And although sadly, the pulsar, which is what the photo on the shirt was, it shows the wavelengths that make up an actual pulsar, has faded over time. The memories and knowing where that shirt came from will always stick with me. And, I might not be able to visit Arecibo, but maybe I can visit some of the other awesome giant telescopes that are in this world of ours. So we actually have one up in West Virginia, the Green Bank Observatory. It's a very famous, very large radio telescope that does a lot of very important scientific work that's not far from me. And that's probably the closest one physically to me. Obviously, seeing the VLA would be a dream come true, but that's all the way out in New Mexico. I have no doubt that I'm going to make it out west at some point with this hobby. And when I do, I will definitely be making a point to visit the VLA. And if you ever go to New Mexico, I would highly encourage you to visit it as well. So why don't we wrap this up with a list of the largest telescopes currently in existence? And, You can define these a lot of different ways. You can say largest telescope in the world, probably 4 different ways, and still be correct, technically speaking. But I thought it would be fun to pick some from kind of the main categories, I suppose you could say, like your optical, your radio, and even your solar telescope, which the size difference between the largest optical and the largest solar telescope is remarkably different, which kind of doesn't really surprise me that much considering how expensive the solar telescopes I've seen are compared to how small they are in relation to the giant, very expensive Schmidt-Cassegrains that we often see. You'll pay 3 times that for a nice solar scope that has a fifth of the aperture in my experience. But anyway, we already mentioned what is the largest single aperture radio telescope in the world. And obviously, originally, Arecibo held that record until 2016 when the FAST telescope in China actually went online. And its aperture is 500 meters, like we talked about earlier. That's 1,640 feet in diameter, which is absolutely crazy. So, nothing even really comes close to that as far as size is concerned, as far as I know, with individual radio telescopes. So that is quite remarkable. Now, that being said, we also have a pretty amazing entry for largest optical telescope. And I say that because it currently holds the record, but it's not going to hold it for too much longer. And when it gets beat, it's going to be crazy how much bigger the next biggest scope is going to be. So this is the largest optical telescope in the world. Right now, that actually belongs to the Gran Telescopio in the Canary Islands. It's actually Gran Telescopio Canarias. I probably am botching that. I'm no good with any words other than English, and I'm only half decent with those. So my apologies. But yes, the Gran Telescopio in the Canary Islands has an aperture of 10.4 meters, which is a mirror that is over 34 feet in diameter, which is kind of crazy to think about, a 34-foot diameter. When we consider that the telescopes that we use in astrophotography, oftentimes have 2-inch to 6-inch apertures, and anything beyond that starts getting into that prosumer level, where you're talking 12-inch aperture, which is kind of mind-bending in my opinion still, to be able to have as an amateur. But then take that and then multiply it times 34 for as large of a mirror as you're talking about. But like I said, that is currently the largest optical scope in the world, but there is one under construction right now, with first light slated for 2028 if all continues to go as planned. And it is in what is, I don't even know if you can say arguably. I think it's definitively the best place in the world to view the stars, which would be the Atacama Desert in Chile. And that's strictly due to the conditions, or really I should say lack of conditions in that part of the world. It's a desert, very high elevation. It's kind of in the middle of nowhere. All of, the best scientists in the world have telescopes in the Atacama Desert. And that is why the extremely large telescope is being built there. Do you notice a trend of astronomers always liking to name telescopes based on how big they are? You got your very large array and then your extremely large telescope. I don't know why, but that always cracks me up when telescopes are named by how big they are. But we had mentioned earlier that the Gran Telescopio Canarias in the Canary Islands had an aperture of 34 feet. The planned aperture for the ELT is 128 feet. So that's mind-blowing to think of a mirror that is 128 feet in aperture. So 39.3 meters, and it will by far be the world's largest optical and infrared telescope, which is actually going to be able to image, a lot of people say, better in some ways than the James Webb, just due to the sheer size of the optical design, which is just absolutely incredible. For good mention, I wanted to mention the nearby, I guess I'll say the hometown hero, which is the Green Bank telescope, is the largest steerable radio telescope. So that means that it's on a movable mount that can be steered and pointed. If you look at a photo of Green Bank, it actually looks like a Dobsonian mount, but just built out in a very ginormous sense. But you can absolutely see the design. You can see what essentially is the secondary, which is taking the reflection of those radio signals. And then there is a curve down below that is very clearly that Dobsonian type mount situation that they've got going on, that allows them to actually rotate and point the Green Bank telescope wherever it is that they would like. And then finally, the largest solar telescope. That actually is located in Maui, Hawaii. It's the Daniel K. Inouye Solar Telescope. It's the DKIST for short. And it is a 4-meter aperture solar telescope, 13.1 feet. So by far the world's largest solar telescope, and is actually able to observe the sun in ridiculous detail. And they use it to study magnetic fields, solar flares, coronal mass ejections, you name it, they can see it with the Daniel K. Inouye Solar Telescope out of Maui, Hawaii. So those are our current world leaders in telescopes, but just keep in mind, it's only been, a few hundred years since the 1-inch reflector that Galileo built. And here we are in the year 2024, heading towards 128 feet mirrors, and then much, much larger radio telescopes. So we really have come a very, very long way as human beings in terms of reaching out and touching the heavens. We still have so far to go. And I really do believe that, as far as technology and science goes, I really do feel like we've only began to scratch the surface as a species in terms of our total understanding of the universe. There's still just so much that we need to answer. And while we're doing very good and making excellent progress, we still have a long ways to go. So let this be a reminder to be peaceful in the world. And let's try to practice peace in our day-to-day lives. And just remember that humans only get ahead when we get along. And we're at a time and place in our world that I never thought I would see again, with all the nuclear war warnings that we are constantly seeing in the news. I mean, I can't open up a web browser and not see something somewhere that says nuclear war. So, I know that you and I can't have any, direct impact on those sorts of big, giant decisions like pressing the red button and launching 100 nuclear warheads at a country, but we can be decent people. And I feel like if everybody could just be a more decent person, then we could keep doing good science and keep learning more as a species. And then maybe one day we could join the undoubtedly other civilizations that are out there in a new way of thinking. So probably won't happen in my lifetime, but that's not to say it couldn't happen in our grandchildren's lifetimes. And the first step to getting there, it's very free and easy. Just be a decent person. So I mentioned the anime last week, Orb, on the rotations of Earth. I haven't watched it yet. I'm sorry. I didn't watch it. I asked you guys to watch it, and then I turned around like a jerk and didn't watch it myself. But the reason for that is I have been just absolutely neck deep in the Silo series, which is actually the recommendation from a couple weeks ago on episode 40 by our friend Rick from Dark Dragons Astronomy. He actually recommended the Silo series. I was on Audible a couple weeks ago, and they were having their big end of year sale, and the Silo series was on there, and I was able to pick up all 3 books for less than $10, I want to say. And because of that, I haven't had time to watch any anime. So I will get around to that, but I only say that to mention Silo is really, really good. So the first book is called Wool, and it's a little bit tough to follow at the beginning. I mean, not tough as in like a difficult read, but you're kind of like, okay, what's going on here? But it all comes to light pretty, I'd say midway through the book. Well, I don't want to spoil anything for you guys, but let me just say it is a very, very good read, and I can't wait to see what happens. It leaves a ton of room for growth in the universe, which is cool because there's already 3 books. I don't know if there will be more, but there's also a show, I believe, that came out. I think it's on Amazon. It might be on Apple, but there is a show for it as well, which I'm very much looking forward to watching after I finish the series. But anyway, I just want to recommend that again. Now that I've gotten into the series, I can definitely back Rick's recommendation of checking out the Silo series. Hugh Howey is the author if you need to look it up, but you can just search for Silo and it'll come right up. Like I say, there is a show for it. It is on Apple TV. I was able to confirm that, but I would highly recommend checking out the books before you check out the show, because they're really, really good, and I can't wait to see how it all ends up. So we will see. Outside of that, for recommendations, let me think here. Have I got anything else that I could recommend? The only game I've been playing is I finally got around to playing Ratchet and Clank: A Rift Apart. It's a game that I wanted to play just because it looked really cool and frankly really pretty. It was like one of the prettiest games that came out on the PS5. And then they finally released it for PC not too terribly long ago when PlayStation finally started releasing some of their games to Steam, for example. So I finally picked it up. It was on sale, and I've really been enjoying that. It's a really fun game, and I don't have to think too hard about it. I was looking for the perfect couch co-op game to play on PC, and sadly, I got to say that it does not exist, guys. There are some really good ones out there, but there's no real great ones. Like, it seems like Nintendo kind of has the lockdown as far as that's concerned, and I hate it because, don't get me wrong, I've got a Switch. I've got 3 Nintendo Switches, in fact, between myself and my wife, and then the old Switch Lite that we have and don't really use anymore. We've got 3 of them. But I'm such an avid PC gamer that I'm always like, PC's got to have a great game to play for multiplayer, but I haven't found it for couch co-op specifically because, we have friends over and we like to hang out and play games like Mario Kart, for example, Mario Party, any of those kind of 3 to 4 player games where people can jump in quite easily. We played a game this weekend called The Ascent, and it had really good reviews for like the multiplayer mode, but I didn't really enjoy it. I don't think any of us did, and it wasn't really designed that well, in my opinion. I don't want to bash it because I could tell whoever made the game, obviously it's a work of love to them, but just not my cup of tea, I don't think, at the end of the day. So didn't really have a great time with that, and we ended up, of course, playing Mario Kart once again. But if you do know any good multiplayer PC games, please feel free to send them my way to astrocast@gmail.com. Finally, I do want to take a moment to thank our sponsor, Dark Dragons Astronomy. If you don't know, Dark Dragons has partnered up with the Astrocast, and we will be working together on a lot of future projects. I actually was talking with Jeff just today, and we are setting up kind of our planning session for our first remote recording episode, which will likely come out over the next, several weeks at some point. We're still kind of in the early stages of feeling some of that out. But we are making progress in that regard, and we definitely plan on having a few more of those posse-style episodes in the future. And then I want to have some one-on-one time with Jeff, obviously, one-on-one time with Rick and Ricky as well. And we'll kind of work it all in as we can over the coming weeks. And that'll just be, another thing to look forward to. We might even start doing a few videos here and there. If nothing else, maybe to drive some more listeners to the show, just because, shorts do so well on things like TikTok and even Instagram and Facebook Reels. And if we could drive more listener engagement or just listeners in general to the show by doing a few simple clips with, various astrophotography photos, then hey, nothing wrong with that. So that's something that we're also exploring. But if you have a need for a solution for your roll-off roof observatory, Dark Dragons Astronomy is the company that you probably are going to want to talk to, because they have designed everything from top to bottom in-house to make it as painless a process as possible for you. They have full backups of power failures in place, remote access via just a smartphone. If that's all you have, you can absolutely open and close your roof if you need to. And they've kind of built the entire Dark Dragon system around reliability being absolutely key. So when you need to know that your roof is going to close, then Dark Dragons is the company for you. So I will put a link to their website in the show notes. And again, Rick and Jeff, very good friends of the show. They are the co-founders of Dark Dragons Astronomy, and they would be more than happy to help you if you have any questions about your particular setup. Please reach out to them. And I would also like to take just a moment here to thank all of our wonderful Patreon subscribers. We've got 14 of you guys now, and I can't thank you enough. It's so cool. The little community that we have built around the Patreon is really, really special. I've had a lot of chats with all of you guys at this point. I've made new friends on the Discord chat that I'm referencing right now. And we swap images and we talk about the mascot and different scene conditions. And I mean, you name it, we talk about it. So if you would like to join us in that endeavor, please feel free. You can give $1 or $5 per month, whatever you prefer, at patreon.com/the Astrocast. And that will get you access to the members only Discord, where you can have, Alex's awesome photo of the Horsehead Nebula looked at, or Astrocast's Captain Cumulus sketch, which, the more and more I look at it, the more I kind of think that might already be the mascot photo, but I can't say for certain. I feel like I'll know it when I see it. But anyway, please feel free to join us there. If you don't want to join the Patreon for whatever reason, and you do still want to support the show, you could also shop via High Point Scientific. We have a unique link that you can use that I'll link in the show notes. And if you make a purchase using that link, you get the exact same price that you would going directly to High Point. But you're able to give a small slice of that to the show. So anybody who does is greatly appreciated, as always. So, guys, I think that is going to just about do it for us this week. I hope that you've enjoyed this episode. I did a lot of research on it, wanting to answer some of the key questions that I had about radio astronomy. Ultimately, what I would like to do is have an actual radio astronomer on the episode, and then I would like for them to maybe listen to my episode ahead of time and then come through and debunk everything that I said, because I'm sure I got a good bit of that wrong. But if you did catch anything in particular that you would like to bring to my attention, I would be happy to put in a correction. You can always reach me at ruastrocast@gmail.com. So that is going to do it for this week, my friends. Thank you so much for tuning in. I am your host, Rue. You have been listening to the Astrocast, and as always, clear skies.